Welcome to a lesson with Dr. Pal. Let's take a look at the idea of a logarithm. So intuitively, what does a logarithm tell you? What is it? How does it work? Well, for instance, if I have something like 8 and I want to focus on something that looks like this, this is a function, all right, or an operator. Just like the square root operator or something else, but it's not square root, it's something, it means something else, but it's an operator, and this is the input into the operator. Notice that the operator depends on this guy. So what does this tell you? Or what are we trying to do? We're thinking quite literally. See how 2 is down below and 8 is up above? Because we're making something that goes like this. 2 to something is equal to 8. We're basically thinking about 8 in terms of a base of 2 and thinking of what exponent makes it. Like how many ideas of multiplication by 2 is 8? It's 3 ideas of it. 2 times 2 times 2. So 2 times 2 times 2 is 8. It's 3 ideas, so this is going to be 3. It's just another way of saying what's the exponent that we need to put over 2 to make 8. What exponent makes 8 over 2? So we put 3 over 2 and we'll get 8. All right. So this idea gives us all kinds of, just from the idea itself, tells us how to work with it. For instance, what if we had something like log base 2, 4 times 8 over 2 cubed. Let's just think about ideas of things that are happening. First of all, how many ideas of multiplication of 2 by 2 do we have here in an expression? This is 2 times 2. There's 2 2's in there. So this is going to be 2 coming from here, this part. What about this part right here? There's 3 of them, right? 2 times 2 times 2, 3 guys. And what about here? 2 cubed. Well, there's 3 guys in here, but what are we doing? We're subtracting ideas, right, of multiplication by 2 here because it's in the denominator. We're dividing by 2 3 times, essentially. So we're going to knock this. So we're going to have 2 ideas plus 3 ideas, subtract 3 more ideas, and we're going to end up with 2 ideas. So this is going to be equal to 2. No, we could have seen that more quickly if we just took 8 and divided by 8 right there, right? Because 2 cubed is 8, and then we just have log base 2 of 4. 2 to what power is 4? It's 2. But why in the world did we have this? So we kind of think about some different ideas that are happening in action. Essentially, what we're doing is think of the output of a logarithm as an exponent. What's the exponent that makes 4? That's what this is, log base 2 of 4. The exponent that makes 4, that's a 2. Okay, what are we doing? Then we're taking the exponent that makes 8. What's the exponent that makes 8? Well, it's going to be 3, right? So take the exponent that makes 8, 3. And then what are we doing? We're subtracting the exponent that makes this guy right here, subtracting off the exponent that makes 2 cubed. Well, notice that 2 cubed right here is 3 times the idea that makes just 1 multiplication by 2. So it's 3 times that idea, right? This gives us a lot of things to work with when we're simplifying algebraic expressions that have logarithms. Of course, right here, this is going to be a 3, subtracting, so 2 plus 3 minus 3, you're going to end up getting 2 as desired. So if we beef this up a little bit, and we're thinking log base, I'll just stick with 2 for now, but what if we had something else like maybe like a plus 1, maybe times x, and maybe it's all over like y cubed. Very similar to this example, but we just changed these with different expressions that could represent different numbers. But we're going to be doing math on ideas, and if you do math on ideas, you kind of need to see what ideas kind of went into play in something simple where you actually had concrete numbers. Okay, so if we have log base 2 of all this, how could we rewrite this? Again, we're not saying what this is. We already know what this is. We're just rewriting it, simplifying it. Maybe if this other form is simpler, maybe this is the simpler form. Sometimes it is. It depends on what we're after. But we're going to practice rewriting so that we know how to go back the other way too, in case this actually would be simpler. So how could we think about this? Think about how many ideas of multiplication by 2 is a plus 1? Like, what exponent do we need to put over 2 to make a plus 1? Well, there's a way of representing that. How do we formulaically represent that? It's log base 2 of quantity a plus 1. That means the exponent we got to put over 2. So what are we doing with that exponent and this exponent? We're adding them. So that exponent plus the next exponent, that will make an x. And then we're going to be subtracting off 3 times the exponent that would make y. Essentially, it's the idea that makes y cubed. But to make it even simpler, we could say it's going to be 3 times the exponent that will make y. So we can say 3 times the exponent that will make y. So we have just taken this log expression and expanded it into a form where we're just kind of thinking about these ideas as follows. Thanks for watching.